Awesome. Beautiful. We have a question here that says, answer all questions. Write your answers in the spaces provided. This is Gcse examination question 1. Is it a curve as an equation? Okay, the curve as an equation, let's see. Y is equal to 3s raised to the power 4 minus 8s cubed minus 3. So our equation is y is equal to 8s cubed, let's see, is equal to 3s raised to the power 4, 3 raised to the power 4, okay, 3 raised to the power 4, and then minus 8s cubed, minus 8s cubed, minus 3, okay, minus 3, okay. And the question says we should find, find I dy dx and I the squared y dx squared. Okay, so let's see the best way to go about it. Okay, so for the first one, okay, our answer will be, so since we know y to be equal to 3s to the power 4 minus 8s cubed minus 3. Okay, so dy dx will give us 12 x to the power 3. Okay, and there's this 24 s squared. So this is our first one. Remember to differentiate, yeah, if we have y, for instance, to be equals to xn, okay, a function f of x to be equals to that y, then to differentiate, yeah, this will be, this implies dy dx is equals to nxn minus 1. Right, so this is how we differentiate, and that is how we'll be able to get 12 s cubed minus 24 s squared. Okay, for our second derivative, okay, that is given, and that is z dy squared y and the s squared will be 12 times 3, that is 36 s squared, and this minus 24. So this is our, so when we multiply 3 by 12, we get 36. Okay, so the same, so all of them, we use the same approach. So this, with this approach, okay, and also second derivative for this same approach. Okay, so we have our, okay, then let's look at the next question. So the next questions says, so we have found this and that, and it's verified that the C has a stationary point when s is equal to 2. Okay, has a stationary point. Okay, let's see. At a stationary point when s is equal to 2. Okay, so that means when x is equal to 2, so that is a stationary point when s is equal to 2. Okay, but is it true? Stationary point when x is equal to 2. Alright, let's see. When at the stationary point, the second derivative must be equal to 0. So let's see what is true. So this implies that our 36 s squared minus 24 must be equal to 0. Okay, must be equal to 0. Must be equal, no, sorry. It must not be equal to 0. Our turning point rather. Okay, so that means the first derivative dydx is equal to 0. Okay, so at the turning point dydx must be equal to 0. And our dydx was dydx as the first derivative was 12 s cubed minus 24x equals to 0. So this implies that 12 s cubed minus 24x equals 0 means 12 x squared x minus 2 is equals to 0. So since x is equal to 0 and x is equal to 2 satisfies the equation, okay, that means as the question, as the what the question was asking for, you see, verify the C as a stationary point when x equals to 2. Yes. So this means s equals to 2. S equals to 2. Since it satisfies the equation at a turning point. So since x equals to 2, yeah, it satisfies the equation at the turning point. Hence, it's true, because at a turning point we have values of x to be equal to 0. Okay, and the turning point, so this is x equals 0 and s equals to 2, both satisfy the equation at a turning point. Okay, that's beautiful. Let's look at the next question. The next question, which is to determine the nature of the point given the reasons. Okay, so to determine the nature of the point, that is how we determine the nature of the point. So to determine the nature of the point, so to determine the nature of the point, we say the second derivative d squared y over ds squared with the value when s equals to 0. Okay, what do we get? Second derivative, we have what is the second derivative? We have 36 s squared minus 24. So 36 s squared minus 24. So substitute these values in here. Then we'll have 36, 0, minus 24. Okay. So this, since this one is less than 0, okay, when the squared y the s squared, and s is equal to 0, the value we got, which is negative 24, is less than 0. Therefore, this is a maximum point. Also, when x is equals to 2, when s equals to 2, when s is equals to the squared y the s squared, or the value of s equals to 2, okay, our equation is 36, 2 squared minus 24, and this value is greater than 0. So, meaning this is a minimum. This is a minimum point. Minimum point when x is equal to 2. So we see that roughly, if we have a line like that, okay, so when x was equal to 0, at that point was a minimum point. When s equals 0 was a maximum point. Okay, so it goes this way. Okay, it goes to maximum point. And when s is equal to 2, that was a minimum point. So this, when s was equal to 2, was a minimum point. Okay, and x, when x is 0, it goes like that. So minimum point when s equals to 2, and when s equals to 0, it becomes a maximum point. So this goes like that, maximum. Yeah, s equals to 0, it's a maximum point like that. So joining the point. Okay, so that is more or less like a cubic. So as we can see, the first one, we're asked to find the first derivative, and we have the first derivative to be equal to 12x cubed minus 24. Okay, our reference is made to the fundamental principles of differentiation. Okay, that's what we use to deduce dy dx. And the second derivative, after we have differentiated the first, from the first derivative, we're able to deduce that for the second derivative. So second derivative was 36 s squared minus 24. When s is equal to 2, at the stationary point, when dy dx equals 0, we find out that x equals to 2 is a solution that satisfies the equation to pose at the stationary point. So since x equals to 2, x equals to 2, since it satisfies the equation at the turning point, the statement is true. Well, we're asked to determine the nature of the point as well. So to determine the nature of the point, what we do is our second derivative, we substitute the respective values we had at the turning point to test or to determine whether the values attained are maximum or minimum. So our values we had, one was x equals to 0, and when we substitute x equals to 0 into the equation, okay, the answer we had, okay, it was negative 24. Negative 24 is less than 0. So that means that point, when x equals to 0, is the maximum point of the curve. Okay, okay, so then when we put in the value of x equals to 2, our answer we had was greater than 0, and that is a minimum point. Okay, so if we say we want to do proper sketch, okay, our sketch will be roughly, let me plot it very well. Okay, so okay, so if s to be 0, so our when x equals to 2, it was going to be a minimum point. Okay, and when x is 0, so we have 1 here, and this may be 0. At that point was the maximum point. So it will go this way. You see? So there's a maximum point. So our rough, or it's a cubic curve, like something like that. Okay, so this is the minimum point. This one s is equal to 0, and this is when s is equal to 2. So there's the maximum point and the minimum point. So max, there's our maximum point. Okay, so x equals to 2 was greater than 0, so this is our minimum point, and this is our maximum point. Right, thank you very much for taking part in this. Please subscribe and also ring the bell so that you'll be the first person to receive our solutions. Thank you very much.